Alright, so we're going to talk about simple harmonic motion, another form of kinematic motion. Remember, when we talk about kinematics, we're talking about motion that without exploring the causes of that motion. So in simple harmonic motion, we're going to have to come up with a couple more vocabulary words. There's a few vocabulary words: position, velocity, acceleration, that are all in simple harmonic motion, but there are a few more that we haven't talked about. The first one we're going to talk about is equilibrium. Okay? When we're referring to simple harmonic motion, we're referring to a point called the equilibrium point. Actually, equilibrium point is the center of my motion. It's when I look at this over and over again, the equilibrium point is the dead center. It's what everything is measured to respect to, in a sense. You can kind of think of it as the origin, but it's really not. If I were to have a mass and I let the mass hang with a spring with a mass hanging on it, and it would just let that mass hang, and then I would set it in motion as it goes up and down, up and down, up and down. The equilibrium point is that point where that mass would normally just sort of hang there, not in motion. In a pendulum, which is another kind of simple harmonic motion, I set that pendulum in motion so it swings back and forth, swings back and forth. The simple harmonic motion is this, or the equilibrium is the center of that motion. This point right here in the pendulum, because it goes up, down, up, down, up, down. This point right here is what would be referred as the equilibrium. There's actually a mathematical reason why we call it the equilibrium point. But that is a discussion of forces. When we get into more topics like forces, we will talk about why this point is called the equilibrium point, or when we're talking about the mass going up and down, why the center of that is considered the equilibrium point. But just for now, realize the equilibrium point is the middle of this wave. I'm referring to it as a wave because in trigonometry you can see that this is a sine wave. So the very center of that sine wave is considered the equilibrium point. Okay? So that's the equilibrium point. The other term that we're going to come up with is amplitude. I'm going to abbreviate it as amp. I will probably make a sticky for the top for amplitude. Amplitude is just referring to the maximum position that wave is from the equilibrium point. So when we refer to the amplitude of something, we're referring to the maximum position that it is away from the equilibrium point. Maximum stretch. Now, that amplitude can also be referring to this down here. It's still a maximum stretch. It's still an amplitude. It's still a value there. This would be a negative amplitude. This would be a positive amplitude. But it's still a maximum. Okay? So, equilibrium is the center of a wave. The amplitude is the top of the wave. Those are some of the vocabulary words that we need to know to talk about simple harmonic motions. The next slide I want to talk about frequency, period, and natural frequency and angular frequency. Okay? So that's on the next one.